Hello students, welcome to my class. In this video we are going to be discussing about sonometer experiment related problems. Let us see the first question. The first question says here, if the tension of the sonometer wire is increasing 4 times, then the fundamental frequency of the wire will be increases by. Tension the wire you are increasing 4 times, and then here what the frequency is going to be increases. And you know frequency, the formula will beginning as F equals to 1 by 2L into conductance, N equals to conductance 1 by 2L into conductance root over T by mu conduct, which is here with this here N is directly proportional to root T conduct. Now here they are asking the second frequency value N2 by N1, which will be equal to conductance root over T2 by T1 conduct, which will be equivalent to, here you are increasing 4 times, so here it becomes 4 times of the tensional force by initial tension force conductance T conduct, which is nothing but 2 you will be getting. That is nothing but here conductance N2 equals conductance 2 times of N1 conduct. Hence here you are going to be increasing 2 times. Let us see the next question. The next question says frequency of the sonometer wire is given as N. Now its tension is increases by 4 times. So here tension you are going to be increasing 4 times, and its length is double, then the new frequency will be there asking. And here N equals to 1 by 2L into conductance root over T by mu. With this here conductance, and here it's related to the tension and length, how it is related in the sense frequency. With this here N is directly proportional to conductance root over T by L conduct, and here conductance N2 by N1, which conductance T2 by T1 into its under root into conductance, it's an L1 by L2 conduct. T2 is given as tensional force is increased 4 times, so here conductance 4 times of tensional force by conductance initial tension conductance T conduct, initial length conductance L conduct, length you are going to be doubling, and here LL gets cancelled, TT gets cancelled. Here N2, which will be equal to, here will be getting as root over 4 in the sense 2 into 1 by 2 you are getting, 2 gets cancelled. Then this is N2 by N1, which is nothing but N2 equals will be getting as N1 will be getting. Means here it means the final frequency also will be equivalent to the initial frequency you are getting. Let us see the next question. The next question says a tuning fork of frequency is given as 480 Hz is given, is used to vibrate a sonometer wire having the natural frequency is given as 240 Hz. The wire will vibrate with the frequency of, means here sonometer, be remember students, sonometer will work on the principle of resonance condition, that is frequency of the tuning fork, which will be equivalent to the frequency of the string you are taking. The wire will vibrate with the frequency of, with what frequency tuning fork is going to be vibrating, 480 Hz. Then here frequency of the string also conductance, the same thing will be getting, that's nothing but 480 Hz will be getting. This is the correct answer. Let us see the next question. The next question says the length of the sonometer wire is tuned to a frequency is given as 250 Hz is 0.6 meter. The frequency of the tuning fork with which the vibrating wire will be in tune, and the length is made to 0.4 meter they are asking. So here frequency, the relation will be beginning as 1 by 2L into conductance root over T by mu conduct. So they are asking to relate the frequency and as well as the length of the wire. That means here N is inversely proportional to, here will be getting as L will be getting. With this here conductance N into L you can make it as constant. That is here conductance N1 L1, which will be equal to conductance N2 L2 conduct. Initial frequency is given as 250 Hz. Initial length is given as 0.6 meter, and here we need to calculate the final frequency into length you are taking as 0.4 meters. Then here N2 which will be equal to, you can take as, this is 250 into, this is 0.6 by, you can take as 0.4 you can take, and this is 2 3 times 2 times it is going, and here 2 125 times 125 into 3 will be getting as 375 heads will be getting. So 375 heads is the correct answer. Let us see the next question. The next question says here, if the tension and diameter of the sonometer wire of the fundamental frequency n are doubled and its density is halved, and then its fundamental frequency will become. And here you are doubling the frequency and the density is becoming half, and here then its fundamental frequency they are asking. Here it's nothing but n equals to, you can take as 1 by 2L into root over T by mu you can take. In terms of density, when you are taking mu you can take as linear mass density. Linear mass density even you can take it as T by mu equals to, here will be getting as mass per unit length. Mass equal to, you can take as volume into density. Volume into density by length you can take. Here area into length into density by L you can take. LL gets cancelled. Even you can take it as area into density. Area is nothing but you can take as pi r square you can take, into density you can take as rho you can take. That doesn't mean here n is directly proportional to, here you can take students T by, here you can take as r square into rho you can take, it's under root. Then here you can take n1 by n2 which will be equivalent to, this is T1 by T2 into, you can take as r2 square by r1 square into rho 2 by rho 1 you can take. It's under root you can take. So here tensional force here, tension and diameter of the sonometer of the fundamental frequency are double, it's given. Tension diameter you are increasing 2 times, radius also it's going to be increases 2 times. Diameter is increasing, means radius also it's going to be increases. So here you can take, this is T1 in this sense, here you can take as initial tension T you can take, and final tension value you can take as 2T, doubling the tension, and R2 becomes, here you can take as twice of this one. So D equal to 2R you can take, D is directly proportional to R you can take, and here that is nothing but, here you can take as 4R square by, here you can take as R square you can take, into you can take as, so density is halved is given, so here rho becomes rho by 2 into initial density you can take as rho you can take. TT gets cancelled, R square gets cancelled, rho gets cancelled. So here in denominator 2 2s are 4 will be getting, in numerator 1 4 gets cancelled, here will be getting as 1:1. That's nothing but, here you can get it as n1 equal to n2 will be getting, that is nothing but initial frequencies n in the sense, here fundamental frequency, here it will be also n will be getting. Let us see the next question students. Here in an experiment with the sonometer, tuning fork of frequency is given as 256 Hz, resonates with the length of 25 cm, and another tuning fork resonates with the length is given as 16 cm. Tension of the string remains constant. The frequency of the second tuning fork is there asking. That means here n equals to, you can take, here it is 1 by 2L into, you can take as root over T by mu. That's nothing but n is inversely proportional to L you can take students. Here with this, here you can take as n2 by n1 which you can take as L1 by L2 you can take. So n2 which will be equal to n1 into, you can take as L1 by L2. Initial frequency is given as 256 Hz is given, and the initial length is given as 25 cm, and here its final length is given as 16 cm it's given. So 16 times it is going, 16 into 25 will be getting as, it is 400 Hz will be getting. So 400 Hz is the correct answer. Let us see the next question students. Fundamental frequency of the sonometer wire is given as n. if the length, tension and diameter of the wire are triple, it's given. The new fundamental frequency they're asking. So it's a length, tension and as well as diameter are double. You just relate the frequency with the tension, length and as well as diameter. Then n equals to, you can take as frequency n equals to 1 by 2L into root over T by mu, you can take, which is nothing but you can take as 1 by 2L into T by here area, in the sense here you can take as pi r square, you can take pi r square into here even you can write it as this one as A into rho, you can take, students, A into rho, you can take A, in the sense here we will be getting as pi r square, we will be getting. So here you can take, it's nothing but 1 by 2L into root over T by pi r square into rho, you can take. Then you just relate with the frequency and the length and as well as radius, you can relate in denominator, and here in numerator you can relate with the tensional force. That's nothing but here you can take as N2 by N1, which will be equivalent to, so it's root T2 by T1 into, you can take as L1 by L2 into, you can take as R1 by R2. This is the denominator value. So here tension force is given as triple is given. So here you can take as 3T by T into L by 3 times of its length it becomes, and R by here it becomes 3R will be getting. LL gets cancelled, RR gets cancelled. So here we will be getting as 3 3s are 9 will be getting, and this TT gets cancelled. Root 3 by here 1 3, you can write it as 3 into root 3 into root 3, you can take root 3 gets cancelled. So here the new fundamental frequency they are given as N2 by initial frequency is given as N, which will be equal to 1 by 3 root 3, which is nothing but N2, which will be equal to N by 3 root 3 is the answer you are getting. Let us see the next question, students. Here a sonometer wire resonates the given tuning fork, forming standing waves with a 5 antinodes is given. Between the two bridges, when the mass of 9 kg is suspended from the wire, when this mass is replaced by a mass capital M, the wire resonates with the same tuning fork, forming 3 antinodes is given for the same position of the bridges. The value of M they are asking. So number of segments are looped for a given frequency formula, students. N equals, we can take as P by 2L into, you can take as root over T by mu. P is nothing but here will be getting as number of loops or segments. It's nothing but here you can take as 5 antinodes is given. So here are number of loops which are nothing but you can take as number of antinodes, you can take number of antinodes. So initially it's given as, let us take N1, here it's going to be producing 5 antinodes. So here you can take as 5 by 2L into, so initially you are suspending 9 kg mass from the wire. So T equal to mg will be getting, that is 9 into g you can take by mu you can take, it's an under root. And the second frequency you can take as, here it is going to be producing the 3 antinodes is given. So here you can take as 3 by 2L into, so root over T by mu. It's nothing but here M, I don't know here how much mass we are going to be suspending, mg by mu you can take. Here the same position of the bridges is given. The wire resonates with the same tuning fork, forming the 3 antinodes. That's nothing but here you can take as N1 equals, you can take as N2. Frequencies you just equate. It's nothing but 5 by 2L into, you can take as 9g by mu, which will be equal to 3 by 2L into, you can take as m into g by mu you can take. And this side mu gets cancelled, here gg gets cancelled, and this side here you can take as L you have to eliminate, and just square on both sides, and 2 side also it will gets cancelled, and here 5 into here root 9 in this is 3 you can take, 3 into you can get it as, this is nothing but root m you will be getting. So this 3 gets cancelled, So 5 which will be equal to root m will be getting. So m square if you are taking m equals to conductors 25 kg. So this is the mass you are going to be suspending for getting the 3 antinodes. Let us see the next question, students. Here a sonometer wire is vibrating in the fundamental mode, is in unison with a tuning fork. Keeping the same tension, the length of the wire between the bridges is doubled. The tuning fork can still be resonance with the wire, provided the wire now vibrates in. Now here you can take, students, the sonometer. It will works on the principle of here frequency of the tuning fork, which will be equivalent to frequency of the string you will be getting, which is nothing but if it is producing p segments, here you can take as p by 2l into you can take as root over t by mu you can take. So keeping the same tension, the length of the wire between the bridges, keeping the tension will be same, it's given, and here it's given as p is directly proportional to, so this here you can take as p is directly proportional to you can take as length of the string you can take. It's nothing but you can get it as p2 by p1, which you can take as l2 by l1 you can take. So here by keeping the same tension, the length of the wire it will be double, it's given. Length of the wire between the bridges is given as double, it's given. That means here you can take as 2l by l you can take. So here ll gets cancelled. It's nothing but here we will be getting as p2 equals to, we will be getting as twice of p1 we will be getting. That means here how many segments we are producing in this sense, here it is going to be producing the 2 segments. Let us see the next question, students. Here a sonometer consists of 2 wires is given of lengths given as 1.5 meter and 1 meter. It's made up of the different materials is given. Right here initial length is given as 1.5 meter and 1 meter, and different materials whose densities are 5 gram per cc and 8 gram per cc is given. The respective radii are in the ratio is given as 4:3, and the ratio of the tension in those 2 wires if their fundamental frequencies are equal. So here you can take, students, n equals to you can take as 1 by 2l into you can take as root over t by mu you can take, which is nothing but here you can take as 1 by 2l into, here you can write it as t by a into you can take as rho you can take. Here area pi r square you are taking, and here you can take as outside it is 2l into, and here we will be getting as t by, this is pi r square into rho you can take. R you can take outside and you just relate with the tensional force, length and radius. So here this is n equals to, here n is directly proportional to, here you can take as consists of 2 wires of length is given whose densities are in the ratio of the tensions those wires if their fundamental frequencies are equal. That doesn't mean frequency also remains constant is given, students. And here you can take tension force you have to relate with this. Here we will be getting as, if you are taken as n equals to, this is 1 by 2 into l into r into here you can take as t by you can take as rho into pi you can take. Then with this root tensional force which is directly proportional to, here you can take as l into r you can take into density also you can take, students. With this here we will be getting as t1 by t2, it's an under root which will be equal to you can take as l1 by l2 into r1 by r2 into you can take as rho 1 by rho 2 you can take. Now here it's nothing but t1 by t2, it's an under root which will be equal to, initial length is given as 1.5 meter, and here the next length is given as 1 meter into radius. Respect to radius or ratios is given as 4:3 is given, densities ratios is given as 5 by 8. It's 5 by 8 you can take, students. Here you can take this one as 1.5, you can write it as 3 by 2, students. Here into 4 by 3 into you can write as root 5 by you can write as root 8, you can write as 2 root 2. This 3 gets cancelled, and here 2 gets cancelled, and here this 2 also gets cancelled. Here we will be getting as root 5 by 2 will be getting. So root t1 by t2, which is nothing but root 5 by 2. With this here you can write as t1 by t2 value you can get it as, by squaring on both sides you will be getting as 5:2. Let us see the next question, students. The length of the sonometer wire is given as 90 centimeter, and its stationary wave setup in the wire is represented by the equation as y equal to 6 sin pi x by 30 into cos 250 t is given, where x and y are in centimeters and t is given in seconds. The distance of the successive antinodes from one end of the wire they are asking. So here the equation you can take, students. Here equation of stationary wave is given as 6 into sin, this is pi x by 30 into will be getting as cos 250 pi into t are getting, and with this here you can take general equation of the stationary wave is 2a sin kx into cos omega t you can take, and instead of k here it will be pi x by 30 will be there. So k equals to you can take as 2 pi by lambda, which is nothing but here you can take as pi by 30 you can take, and here pi gets cancelled. Lambda value will be getting as 2 into 30, just cross multiply, which is nothing but 60 centimeters you are getting. So distance between two successive antinodes is nothing but between successive antinodes are, that is x equals to you can take as lambda by 4. It's an integral multiples of the, right, lambda by 4 will be getting 3 lambda by 4, 5 lambda by 4, like and so on will be getting. Lambda value will be getting as 60 centimeter. When you are putting these values here, 60 by 4 will be getting as 15 centimeter, and here will be getting as 3 lambda by 4 lambda if you are substituting 4 15 there, 15 3 0 will be getting as 45 centimeter, and the next here will be getting as 75 centimeters you are getting. So position of the antinodes will be getting as 15 centimeter, 45 centimeter and 75 centimeter is the correct answer. Antinodes in the sense here maximum amplitude will be getting, students. Maximum wavelength here in sine function will be getting as, it's a sine pi x by 30, which will be equal to you can get it as plus or minus 1 will be getting, that's nothing but pi x by 30, which will be equal to then 90, and here sin 90 will be getting as 1 will be getting sin 90, this is pi by 2. Next 3 pi by 2 in the sense here sin 3 pi by 2 is minus 1, and here you can get it as 5 pi by 2 and so on will be getting. So here pi when you are removing in the sense x value will be getting as, or else pi x by 30 which will be equal to, here you can get as pi by 2 when you are substituting, here pi gets cancelled, so 2 15 times will be getting, then x equal to will be getting as 15 centimeter will be getting. And by comparing antinode condition also even we can get the answer, students. Let us see the next question. The bridge of the sonometer is slightly displaced so that length of the wire is decreases by 0.5% is given, and the tension of the wire is increased by 1%. The fundamental frequency of the wire they are asking, and n which will be equal to, here will be getting as 1 by 2l into root over t by mu. That's nothing but n is directly proportional to, you just relate the string frequency with the tensional force and length, students. It's nothing but here for small changes here you can take as delta n by n, which will be equal to, you can take as this one, even you can write it as t power 1 by 2 by l you can take, which is nothing but 1 by 2 into delta t by t plus here this is nothing but l, you can write it as delta l by l you can get. For small changes, this is a procedure you have to take, students. Delta n by n, which will be equal to 1 by 2 into delta T by T is given as tension in the wire is increased by 1%. It's given as 1%, plus here will be given as delta L by L. So length is decreasing, 0.5% is given. So here you can take as delta L by L value, you can take as 0.5 you can take. So 1 by 2 is nothing but 0.5, and here plus 0.5 will be getting. So then delta n by n value will be getting as 1% you are getting. This is a 1%. So 1% is an increased value you can take, students. Now let us see the here the next question says a sonometer wire with the suspended mass is given as m equal to 1 kg is in resonance with the given tuning fork. The apparatus is taken to the moon, where the acceleration due to gravity is given as 1 by 6 that of the earth is given. To obtain resonance on the moon, the value of the m should be. Then frequency, here the formula will be getting as for a sonometer wire 1 by 2L into, you can get it as root over T by mu, students, which is nothing but T is nothing but tension in the string you can take, and here which is nothing but you can get it as m into G you can take, which is given as constant is given. That means here you can take as m2 G2 will be equivalent to m1 G1 you can take, and initially here m2 into G2 is given as you are taking the moon, so G becomes 1 by 6, so G2 equal to G by 6 you can take, and initial mass is given as, here it is given as 1 kg, it's given 1 into this G value you can take, this is the G you can take, G gets cancelled, then m2 the mass will be getting as, here 6 into 1 will be getting as 6 kg you are getting. This is the correct answer. Let us see the next question, students. The length of the sonometer wire tuned to a frequency of 256 Hz is given as 0.6 meter. Calculate the frequency of the tuning fork with which vibrating wire will be in tune when the length is made up of 0.4 meter. So here you can relate, students. Here n and L you have to relate. N equals, the formula 1 by 2L into, you can take as root over T by mu. So here n is inversely proportional to, here you can take as L you can take, students. It's nothing but here you can get it as n2 by n1, which will be equal to, you can take as L1 by L2. So here this n2 value we can calculate, students. That's nothing but n1 is given as initially 256 Hz is given, 256 Hz, which will be equal to L1 is given as 0.6 and L2 value is given as 0.4, 2 3s are 2 2s are you can take. Then here n2 which will be equal to 3 into 256 by 2 you can take, 2 1s are 2 2s are 2 8s are will be getting, and 128 into 8 you can get it as nearly so you will be getting as 384 Hz you will be getting, students, 384 Hz. It's a correct answer. Let us see the next question, students. And the next question says, to increase the frequency by 20%, the tension in the string vibrates on a sonometer has to be increased by. So initially you are increasing 20%, then the here tension in the string vibrates with what frequency? Now here n equals will be rating as 1 by 2L into, we can take as root over T by mu. So here n is directly proportional to, here will be getting as root T will be getting, which is nothing but you can take as T is directly proportional to n square you can take. So here sonometer tension in the wire can be increased by, that's nothing but T2 minus T1 by T1 into, you can take as 100 you can take, and here n square when you are talking this is, here you can take as n2 square minus n1 square by, it is n1 square into 100 you can take, students. Here n2 is nothing but, here will be getting as So here it's given as 120%, 20% you are increasing, that's nothing but will be getting as 120 whole square. So initial one value you can take as 100, you can take students, by initial value will be getting as 100 whole square into you can take as 100, you can take this 100 gets cancelled. So here when you are taking outside, denominator 100 will be there, in numerator you can take as 10 square, in denominator 100 will be there, the remaining in this sense here will be getting as 12 12 are 144 minus 10 10 will be getting as 100 will be getting. This 10 square and this 10 square 100 gets cancelled. 144 minus 100 will be getting as 44% will be getting. So here you can write as 44 is the correct answer. Let us take the next question, students. Here a sonometer wire fixed at one end has a solid mass M hanging from its other end. To produce the tension in it, it is found that 70 cm of the length of the wire produces a certain fundamental frequency when plucked. When the same mass M is hanging in water completely submerged in it, it is found that the length of the wire it has to be changed by 5 cm it's given. In order that it will produce the same fundamental frequency, calculate the density of the material of the mass they are asking. Here N you can relate, student. Initially you are placing hanging from its other end. Initially you are placing the air medium, later you are placing in the liquid medium. So N equals you can relate as 1 by 2L into you can take as root over T by mu. It's nothing but here you can take as L, how it is related to the tensional force in the sense L is directly proportional to you can take as root T you can take, which is nothing but L1 by L2 which will be equal to T1 in the sense here initially you are suspending some mass, that mass you can take as mg you can take, by later you are suspending in the liquid. When you are suspending in the liquid it will experience the buoyancy force, so that you can take as mg into 1 minus density of the liquid by density of the body you can take. This is here under tensional force you can take. mg gets cancelled. Then here by squaring on both sides, here we will be getting as 1 by L2. So here I am just reversing, students. Here you can write as L2 square by square, reversing and squaring, L2 square by L1 square which will be equal to, this is rho b minus rho L by rho b will be getting, when you are reversing here we will be getting as 1 minus so 1 minus here you can write as density of the liquid by you can write as density of the body you can take. Here you can rewrite this one, students. Here 1 by here will be getting as 1 minus density of the liquid by density of the body will be getting. Then by squaring on both sides here by reversing this one, here we will be getting as L2 square by L1 square it becomes, now it becomes here in denominator it becomes the numerator value 1 minus density of the liquid by density of the body you can take. So with this here you can write as density of the liquid by density of the body which will be equivalent to 1 minus, this is L2 square by L1 square you can take. So it's 1 minus L2 in the sense here will be getting as, so initially when the same mass M is hanging in the water completely submerged in it, it is found that the length of the wire it has been changed by 5 centimeter. So here same mass M is hanging water incompletely, completely, then here it will experience the buoyancy force, so that so total length value it's going to be decreases, length is going to be decreasing due to the buoyancy force. The buoyancy force here, this is a tensional force it will act and buoyancy force it will act, and here down it will be weight of the body it's going to be acting. So here we will be getting as 1 minus density of the liquid by density of the body you can take, which is nothing but here 1 minus. So length when you are placing inside the liquid in the sense here it's going to be decreasing, changes by in the sense it's a decreased value you can take 5 centimeter. That means here you can take as 65 whole square by you can take as L1 square, L1 in the sense here you can take as 70 whole square you can take. So when you are doing LCM, density of the liquid by density of the body which will be equal to 70 whole square minus 65 whole square you can take by you can take as this is 70 you can take student. This is 70 whole square you are getting. So when you are simplifying this one and all, here you will be getting as it's a 196 by here you will be getting as 27 into this is density is given, or else you can take as 70 it will be 4900 by 4900 minus, and this will be here will be getting as this is wait a moment student, here will be getting as this is density of the liquid by density of the body, which will be equivalent to 1 minus 65 whole square by 70 whole square will be getting. It's nothing but here you can take as 70 whole square minus 65 whole square by you can take as 70 whole square you can take. And here density of the body, if you want calculate here density of the body, which will be equivalent to 70 whole square by you can take as 70 whole square minus you can take as 65 whole square you can take, which is nothing but here will be getting as 4900 by 4900 minus this is the density of the liquid also you can take students into density of the liquid, that's a 4225 will be getting. With this here we will be getting as into density of the liquid you can take. So density of the body which will be equal to here when you are simplifying this one here we will be getting as 196 by 27 into density of the liquid you are taking. So here it is given as density 196 by 27 completely filled, and here calculate the density of the material they are asking. Density of the liquid is nothing but 1 gram per cc you can take students. 1 gram per cc is nothing but it's 196 by 27 into 10 power 3 kg per meter cube you can take. So when you are simplifying 196 by 27 we will be getting as nearly 7.26 into 10 power 3 kg per meter cube you are getting. 7.26 into 10 power 3 kg per meter cube. This is the correct answer. Let us see the next question students. Here a stone is hung in a air medium from a wire which is stretched over a sonometer. The bridges of the sonometers are given as L centimeter apart when the wire is in unison with a tuning fork of frequency is given as N. When the stone is completely immersed in water, the length between the bridges is given as L centimeter for the re-establishing the unison. The specific gravity of the material of the stone they are asking. So they are producing unison students here, that means frequencies will be same. N equals you can take as 1 by 2L into you can take as root over T by mu. Length and T when you are relating, L is directly proportional to root T you will be getting. Initial length is given as capital L is given and final length is given as small l is given, which will be equivalent to here tension force initially you can take in the air medium by tension force you can take in the water you can take, which is under root, which is nothing but here in the air medium T is nothing but mg by in the water in the sense here mg into here you can take as 1 minus density of the liquid by density of the body you can take, it's an under root you can take, mg gets cancelled. Then by doing square on both sides here L square by L square which will be equivalent to 1 by here you can write as 1 minus density of the liquid by density of the body you can take. So it's nothing but 1 minus density of the liquid by density of the body which will be equivalent to here you can write as when you are reversing this one here you will be getting as L square by capital L square you can take students. And now here you have to simplify this one, 1 minus L square by capital L square which is nothing but density of the liquid by density of the body by taking LCM L square minus L square by L square which will be equal to density of the liquid by density of the body. That's nothing but here they are asking here specific gravity of the material of the stone. Specific gravity is nothing but density of the body by density of the liquid you can take, which is nothing but here will be getting as L square by capital L square minus small l square you can take. So this is nothing but here will be calling as the relative density or specific gravity will be called. So it's a capital L square by, here we will be getting as L square minus small l square you are getting. Let us see the next question, students. Here it's given as two wires of radii is given as R and 2R is given. It's welded together at the end. R and 2R it's given. The combination used as a sonometer wire and it's kept under a tension of T newtons. The welded point is midway between the bridges. The ratio of the number of the loops formed in the wire such that the joint is a node and when the stationary vibrations are set up in the wires. Two wire sets given from the combination used to produce a sonometer wire and is kept under the tension is given as T is given. Such that joint is node and here vibrations are set up in the wires. So when you are combining here what you can get, students, you can take as here you can take as pth harmonic of wire 1 you can take coincides with qth harmonic of wire 2. Qth harmonic of wire 2 will be getting. That means F equals here you can write it as, or N equals you can write as P by 2L into you can take as root over T by mu. Instead of mu you can take as A into rho you can take pi r square into rho you can take. For Q segments here will be getting as Q by 2L into you can take as T by pi into rho into. So here radius is given as 2r. That's nothing but 2r whole square means here you can take as 4r square will be getting. So T by pi r square and T by pi rho r square gets cancelled and here we will be getting as this 2L gets cancelled. Then here we will be getting as a P by Q which will be equivalent to here you will be getting as in denominator will be root over 1 by 4 which is nothing but 1 by 2 will be getting. So 1 by 2 is the correct answer.